Hey guys, this is the first lesson from chapter 7, and we're going to talk about simplifying a radical expression. So, this is something that you've definitely had before, but we're just going to revisit it. So, a simplified radical has these four things: it has no nth power of nth roots, and we'll talk about that. It has no fractions inside of radicals. So, this is where some people make mistakes. It has only one radical per term and it doesn't have any radicals in the denominator. So that's something else that I see a lot as well. So the first thing I want you to do is just go through here and we're going to find the perfect squares. So go ahead and fill those in. Okay, so a lot of times people have some issues with, well, I don't know, how I can take the square root of this, or can I take the square root of this? So this is a nice list. All of these are perfect squares, and you can take the square root of all of these numbers here. And so, like, for instance, the square root of 289 is 17. The square root of 576 is 24. So this is kind of a handy reference to have. Okay, so we're going to go to perfect cubes. So a lot of times people make the mistake like this is 3, but it's like 1 times 1 times 1 is 1. 2 times 2 times 2 is 8, and so forth and so on. So go ahead and figure that out. These are powers of 2 and powers of 3. So go ahead and do all those. Okay, so if I wanted to take, let's say, the cubed root of 64, the cubed root of 64 is 4. So that's how you kind of deal with perfect cubes. These are all powers of 2, which we will get into, and powers of 2. So this is also another nice reference. Okay, so let's go ahead and get into some problems. So we're going to simplify each expression. So the first thing that's going through my mind is I want to find a factor of 28 that's a perfect square. And I want the biggest factor of 28 that's a perfect square. So I'm going to go up here to my perfect square list. I'm going to say 1 doesn't really count because it goes into everything. But I already forgot the number. What is it? 28. Does 4 go into 28? Does 9 go into 28? Does 16 go into 28? And I believe that 4 is the biggest factor that's a perfect square that goes into 28. So what we're going to do is we're going to split it up into 4 times what is 28? And it's 4 times 7. So we can split it up like this. We can also split it up like this. And so when I can't take the square root of this one, but when I take the square root of this one, that's 2. So my answer is 2 square root of 7. So see if you can follow that process for the next 3. Okay, so so these are my answers. This ended up being a perfect square, 225. So let's go up here. 225, the square root of 225 is 15. So I could just jump to that. These two down here, we're going to talk about maybe you didn't see the biggest factor. So let's pretend that for 32, you just saw that 4 was the biggest factor. So 4 times 8 is 32. So I'm going to split it up. So the square root of 4 is 2 square root of 8. That's okay. We can still get here. We're still not at the right answer yet. But notice that 8 is hiding a perfect square factor as well. So 4 times 2 is 8. So I'm going to split this up into 2 times the square root of 4 times the square root of 2. Well, the square root of 4 is 2. So I have 2 times the square root of 2, which is 4 square root of 2. So notice I'm getting there. It just takes some extra steps, and that's okay. But really ask yourself when you get done, is this still hiding a perfect square? And if it is, just keep going. Okay, so now we're going to deal with some different roots. So we're going to start here. Notice that there's a 3 here. So I'm going to go up here and find, oops, sorry, I went too far. I'm going to find the biggest cubed root that goes into 54. So 54, think about the factors of 54. See if you can do that one. Okay, so the cubed root of 27, that is a perfect cube, is 3, and I can't take this any further. So my answer is going to be 3 cubed root of 2. Okay, so what if we have a 5th root? So what you might have to do is make a 5th root list. off to the side. So you might just want to go through and see like 1 to the 5th power, 2 to the 5th power, 3 to the 5th power, 4 to the 5th power, and keep going and see what's something really big that will go into that. Okay, so I'm going to give you a hint. Whenever you see like, so a bunch of zeros, that's what I want to say. So let's see the pattern here. So 10 to the 2nd power, 10 to the 1st power is 10. 10 to the 2nd power is 100. Notice that it has 2 zeros. 10 to the 3rd power is 1000. Notice that it has 3 zeros. So 10 to the 5th power, that's going to have 5 zeros. So 1, 2, 3. So that's what I was noticing here, is that this has 5 zeros. So I could take the 5th root of 100,000 times 7 and it would work. So just kind of be on the lookout for that. If those match up, that's kind of a nice trick. So this, the 5th root of 100,000 is 10. So my answer is going to be 10 times the 5th root of 7. Okay, so these two are 2 others. See what you can do with those. Okay, so on this one, this is just a cubed root. So I went up to my cubed root list and I said, okay, well, what is the biggest thing? What is the biggest factor that's a perfect cube of 32? And it was 8. So that's where I started. 8 times 4. The cubed root of 8 is 2, and that was my answer. Okay, so I have this weird root, and you're more than welcome to come up here, but this is what I choose to do. Whenever I see just kind of a weird root, I just make a perfect 8th list. So then I'll say like 2 to the 8th power. I'll type that on my calculator. So 2 caret 8 is 256. 3 caret 8 is 6,561. So notice like these get really big really fast. So I know that these are going to be too big. And if 1024 has a perfect cube, it's going to be 256. So I'm going to say 1024 divided by 256. And sure enough, 256 times 4 is 1024. So that's my thought process there. So I'm going to split it up. The 8th root of 256 and the 8th root of 4. We know the 8th root of 256 is 2, so my answer is 2 8th root of 4. Okay, something else I want to point out is this is the same thing as to the 1/2 power. So I want to show you what happens. So if I take x squared raised to the 1/2 power, when you raise a power to a power, you multiply. So half of 2 is 1. And so we're just left with x. The same thing here. So I have x to the 3rd power raised to the 1/3 power right there. So it just cancels out to x to the 1st power. Same thing here. My answer is x and my answer is x. So just kind of be on the lookout for that. Okay, so this is a very important rule that's going to come up. So if you have an even exponent and you take an even root of that and it comes out odd. So I changed my 8 to a 2. So I'm going to start off easier. So the square root of x squared. Well, we just found out up here that the square root of x squared is x. So what this is it's truly x to the 1st. Well, since you have an even divided by an even and it comes out odd, you are only taking the positive. So you want the absolute value of that answer. So let me show you how this works. So if I have like m squared and the square root, my answer is going to be the absolute value of m. B to the 18th, and I'm taking the square root. So again, guys, that's the same thing as b to the 18 divided by 2 power. So that's the same thing as b to the 9th power. So I have an even, and it came out odd. So I'm going to include the absolute value bars. Okay, now notice this, guys. I have 15 divided by 3 because that's my root. So I have y to the 5th power. Do I need to put absolute value bars on this one? It's odd, but neither of these are even. I don't have to worry about it. This is what it is. Notice this 24 divided by 4. I divided this. So this is 18 divided by even. It ends up being an even exponent. So again, I don't have to put absolute value bars on it. So just kind of keep that in mind when you're doing those.